In this video for section 5.2, we're going to do exercise 37 from the homework problems, and you're going to see a similar problem in your homework. At a college production of A Streetcar Named Desire, 400 tickets were sold. The ticket prices were $8, $10, and $12, and the total income from ticket sales was $3,700. How many tickets of each type were sold if the combined number of $8 and $10 tickets sold was 7 times the number of $12 tickets sold? So we have three different ticket prices here, the $8, $10, and $12 tickets, and that tells me that I need to have three variables. And I also need to have three equations in order to be able to solve. So I'm going to let x be the number of $8 tickets. I'm going to let y be the number of $10 tickets, and I'm going to let z be the number of $12 tickets. So, some of the information that I have is the total number of tickets sold was 400. So if x is the number of $8 tickets, y is the number of $10 tickets, and z is the number of $12 tickets, adding all those together, that is going to equal 400. I also know the total income from ticket sales was $3,700. So if I multiply the number of each type sold times the cost of that ticket, add all those together, that should equal 3,700. So 8x plus 10y plus 12z equals 3,700. Now I need to write a third equation, and that comes from this information right here. The combined number of $8 and $10 tickets sold was 7 times the number of $12 tickets sold. So I need to turn that into an equation. So the combined number of $8 and $10 tickets sold, that's going to be x plus y. X is the number of $8 tickets and y is the number of $10 tickets. Combining them just means that I'm adding the two numbers together. Was 7 times the number of $12 tickets sold. Now when you see the word was here, you can think of that as a shortcut for was equal to. So if I use was equal to, then that tells me that my equation is going to have an equal sign. 7 times the number of $12 tickets sold. Well, that's going to be 7z. Now, in order to solve a system using addition, if you remember we talked about back in section 5.1, we need to have all the variables on the same side of the equation. So now is when we're going to need to use that. This third equation does not have all the variables on the same side. I need to move over either 7z or x plus y. It's easier if I move over the 7z, and I do that by subtracting it from both sides. And so that gives me x plus y minus 7z equals 0. So altogether, my three equations here, I'm going to rewrite them. We have x plus y plus z equals 400. We have 8x plus 10y plus 12z equals 3,700. And we have x plus y minus 7z equals 0. So now we need to solve this system in order to find the numbers for x, y, and z. So what I'm going to do is I'm going to start with equations 1 and 2 and put those together. So this is 1, 2, and 3. And I'm going to be eliminating x. So if I do this, now the nice thing about these problems is that the numbers generally are a little bit nice to work with here. So what I need to multiply if I'm eliminating x is I need to multiply the top equation by -8. So I'm going to do that. Negative 8 times 400 is negative 3,200. So x's cancel out. We have 2y plus 4z equals 500. So now I need to pick another pair of equations, and I need to again eliminate x. I'm going to go with equation 1 and 3. So I'm going to copy these down. Now something nice happens when I work with equations 1 and 3. And we're going to see this in a second. Looking at this, I have x. If I'm eliminating x, they both have a 1 in front, or they both don't have anything in front. I need to make one of them negative. So I'm going to make the bottom equation negative by multiplying by negative 1. So my top equation is going to stay the same. In my bottom equation, I'm distributing that negative 1, so that's going to be minus x minus y plus 7z, negative times negative changes to plus, and negative 1 times 0 is just 0. Now, when I go to add these together, something really nice happens because my x's cancel out and my y's also cancel out. So just like that, I automatically get the value for z. So if I add these, I have 8z, 1z plus 7z would be 8z, and 400 plus 0 is 400. So I don't need to even put the two equations together at this point because I'm going to get one of the variables right now. So 400 divided by 8 gives me a value of z equals 50. So what I'm going to do now is I can find the value of y by substituting into this equation. 2y plus 4 times 50, plug in 50 for z, equals 500. So we have 2y plus 200, and solving that for y, this is one of those problems that takes up pretty much a whole page of paper. I get 300 divided by 2, which is y equals 150. And then lastly, I need to solve for x by plugging into one of my original equations. Now the easiest equation to use is going to be this top one, x plus y plus z equals 400. So x plus 150 for y plus 50 for z equals 400. 150 plus 50 is 200, and solving this gives me a value of x equals 200. So, in terms of a sentence I could write, there were 50 $12 tickets sold. Actually, I'm going to start with x because I think that's the order that the homework will go in. If I can get my eraser here. There were 200 $8 tickets sold. A 150 $10 tickets. And 50 $12 tickets. So now you can go ahead and do the homework problem for this section.